Chairperson, ladies and gentlemen, my name's Alex and I'm here today to talk to you about Gustav Robert Kirchhoff and his contribution to circuit analysis. Robert Kirchhoff, born in 1894 and died in 1887 at 67 years old, is famous for more than just what we are taught about. For example, he made grand contributions to the field of spectroscopy and thermochemistry, and whose work on thermal radiation directed future physicists such as Max Planck in quantum mechanics. However, the scope of this presentation will just be focusing on his laws of circuit analysis, or more specifically, Kirchhoff's current law. Now, KCL can be expressed algebraically as the sum of all currents entering a node is equal to the sum of all currents exiting the node. Here is a visual representation of KCL in action, representing conventional current flow, or the flow of charge from the positive to the negative terminals. This is different from electron flow, or what is actually happening in conductors, as proven by Joseph Thomson in his famous cathode ray tube experiment. In this example, it can be seen that the rate of flow of charge through the 5K resistor is 1/6 the speed of the source, and the rate of flow through the 1K resistor is 5/6 the speed of the source. Now, while being highly intuitive, KCL is extremely versatile and an essential tool for circuit analysis involving multiple branches of a network. The current will always divide among the branches of a network, respective of the total resistance within that branch, and travel back to the source with the same magnitude, assuming no losses. It can be seen in this test circuit that there are two total nodes and two branches with separate resistances. Once the source current has been calculated via determining the total resistance, KCL can then be applied to determine the current through the different branches. As seen through this formula, which we are all very well familiar with, the source current is equal to, in this case, I1 plus I2. And using this simple current divider rule, we can get a value for I1 and I2 respectively. So why does KCL hold true? The law of conservation of charge, just like energy, cannot be created or destroyed. The law of the conservation of charge states that the total amount of electric charge in a system does not change with time. It's a fundamental law. Note that KCL holds true for any circuit where there are multiple branches, even in AC circuits. References and sources.